Okay, time for another FilaCube filament. As you might have guessed, based on how many videos I've done about these guys, this is probably my favorite filament right now. They don't have the silky, shiny colors, but any other color, black, white, blue, mint blue, and so forth. They have really nice filament. It's made in the USA. And it's very prints very consistently from reel to reel. They also have a really good vacuum seal on all their reels, which is always a sign of quality. So we'll open this up. And they have a desiccant pack in here. Let's put that in the dry box for extra buffering. So this is an interesting color. It's actually grayish-brown. So that's kind of a strange color. But I have a new special product I'm coming out with. This is the right color for what I need it for. So anyway, we're going to do the usual test with this. We're going to do a temperature tower, a bed adhesion and layer adhesion and cracking test, and then we're going to do a fun print of a grizzly bear. So this is a good color for grizzly bears. That's not my product, but so we're going to see if we got our money's worth. So we always save a empty reel so we can check to see how much we've got left on the reels when they get down low. So we'll turn it on. So by putting this on here first, this makes the 0 point how much the reel weighs. So now when we take this off, we get the net weight of the reel. It looks like we got shorted. We got shorted by 53 grams. So this is the first FilaCube reel I've been shorted. Usually they're over by at least 10 to 50 grams. So it does say plus or minus 50, 1 kilogram plus or minus 50. So it is not within 50. It's 53. So their quality control fell down a little bit, but usually we get a little extra. So I guess we'll call it even. All right, so let's put this on the machine, and we'll see how it does. Here we are with our regular temperature tower. We're printing all of our PLA at 225, and I don't expect this to be any different. But it's a good idea to do it anyway, just to see. You never know. So with this OpenSCAD project, you just enter your starting temperature, which is the temperature at the bottom, and your ending temperature, the temperature at the top, and your interval, which is 5 degrees. And then when we get into Simplify 3D, we will set up a temperature profile in there to match these bridges. So this is a project on Thingiverse that I'll have a link to in the show notes. So let's go over to Simplify 3D and we will set up our temperature profile. So here's the temperature tower in Simplify 3D. And we can go to the settings. This is like a profile. They call it a profile. So all these first things are pretty standard. The only thing we're changing over here is the temperature. So we're using a bed temperature of 40, which has worked really well for us for quite a while. So we're going to stick with that. And then here is where the magic comes in. At layer 1, which is at the very bottom here, we're going to be putting at 230 and up through this first bridge, into this first bridge. So up through layer 52, we're going to be at 230 degrees. Then we're going to switch to 225 for this bridge, and so on down to 210. And for cooling, we're going to do 100% at layer 2. I was experimenting with lower cooling when it was really really cold last winter, but that didn't really work out, so I'm going to stick with this. So as most PLA, at layer 2 you start using 100% fan. That's been my experience. Alright, so that's ready to go. So we say prepare to print. It takes about 55 minutes to print this tower. So we'll save that to an SD card and we'll go over to the time lapse and watch it. Looks like a good print. Let's get it off of the One thing I changed about this project just recently is instead of the default for Simplify 3D is to go all the way down to the bottom, which is 140. For this printer is 140 Z direction. But then you have to, it's hard to get stuff off at that level, and these things are short, so I changed it to only go down to 100. So if it's at 100, then it's easy to get out. Alright, the bed adhesion was good. Bottom looks super clean. All of the prints look pretty good, all the temperatures. Even up to 230, very little sagging. There is some sagging at 225 and 220. So you probably could fit this lower. Again, but the pointy thing at say 210 is not looking that great. So it looks best. 220 looks the best, but I think I'm going to keep printing at 225 because I'm printing everything else at that. So at some point I may drop down to 220 as my standard, but I hate to mess with success, so we'll just stick with 225 and we'll do the bed and layer adhesion test next. Okay, so there's our temperature tower. We printed well at 225. That's our goal temperature. So this is a layer and bed adhesion and cracking. So by printing out a rectangle like this, you can see whether your alignment is good of your print bed, but also whether the corners are curling up. If you don't have a good adhesion to your print bed, these corners will curl up. So that's what that's testing. And then layer adhesion is what the how each layer bonds to the layer before it. So as you're printing this vertical rectangle here, if you have good layer adhesion, this joint is super strong. This is the weakest point right here at this corner. So if you have poor layer adhesion, then this will crack. And then I have the raised and inset letters just to see how it prints on a flat surface. So if you have overheating problems, you can get bubbling around these letters and so forth. But if this looks nice and clean, the same with this one, then everything's printing well, and you're probably dialed in not only your temperature, but also your cooling. So your bed temperature for your adhesion, your extruder temperature for your layer adhesion, and also the cooling affects layer adhesion. So if this prints well, then you're pretty much dialed in and you can go on to real projects. So we'll try this on the printer by going to Simplify 3D. So I'll go to that next. So here's that OpenSCAD project. Again, this is I'll have a link to this on Thingiverse. This is one I made up after trying some different ones, and this one seems to work the best for me. So this is in Simplify 3D. And in this case, we're not using a temperature gradient. We're just using a single temperature, the one we decided on. So the bed temperature is again 40, which is what we wanted, and the layer temperature, the temperature for all the layers is 225. And for cooling, we're doing 100% at layer 2, which is what we did before. So let's see how long this is going to print. 53 minutes. That's a nice time. I try to keep these test projects to less than an hour, otherwise it takes too long to do anything. So I want to get to real printing. So I want to make sure I'm dialed in, but I don't want to waste time printing elaborate test projects. It doesn't really add that much. At least I have enough experience now that if this is printing properly, then I'm dialed in, so I can just go on to real things. Okay, so we'll send this over to a SD card, and then we'll switch over to the time lapse and actually print this. Corners are solid, they're not curled up or anything. And we'll check the bed adhesion, looks good. Solid but not too hard to get off. Bottom looks really clean. A little bit of gapping here, that's not good. 。 really strong. It might be time to replace the heat break tube and nozzle. So since I'm printing and selling stuff, and I'm printing enough that I'm pretty much printing every day for 10-12 hours a day, pretty much. I mean, I have a few days off here and there, but based on my experience, I've been finding that if you change out the heat break nozzle before you really get a lot of extruder problems, save a lot of headaches. So anyway, as far as strength goes, the layer adhesion is really good. So this doesn't really affect the strength of it, but that's cosmetically that doesn't look good. So based on how much I'm printing, I've come up with a kind of a rule of thumb that I want to change it every 60 days. So it's been 60 days. I think 60 days a week ago, and I said, well, it's still printing okay. So maybe I'll just go ahead and change it. I've changed it enough times, and in fact, hopefully the video about how to change it and stuff will come out before this. I think it will, yeah. In fact, my testing that I did when I decided to change it every 60 days should have come out already. In any case, I'm going to go ahead and print the Grizzly Bear, which is our fun print. But I think after this, I'm going to change out the heat break too before I do anything else. So. In any case, the lettering looks fine, and so I think it's a good temperature. This brings up a point about the 225 versus 220. So I think probably this filament would print great at 220, but with 225, if you're starting to get some clogging, minor clogging in your heat extruder, then the 225 will keep it going a little bit longer because it's a little bit hotter, so it'll be able to move the material even though it's starting to clog up a little bit. So that's one reason I like a 225, because everything comes out cosmetically good except for this, of course. And we'll see how the bear comes out. That'll be a good test right there. Okay, so on to the Grizzly Bear. Growl. Grrr.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.